Assalamu alaikum wa rahmatullahi wa barakatuh, dear grade 9 students. As I promised you that I'm going to make training exercises and videos. And in this video, I'm going to talk about two geometrical training exercises. Talking about right isosceles triangles, semi-equilateral triangles, any right triangles. So we are going to talk about the properties of a right isosceles triangle, the hypotenuse, the sides in a semi-equilateral triangle, and as well as Pythagoras theorem. As well as we are going to talk about the midpoint theorem and its converse. So hope you enjoy these videos, and as Mrs. Houda always say, go east, go west, geometry is the best. Let's get started by the first exercise. And here we go. Here is a figure. As you see, we have two right triangles. One of them is called FBA and the other is called ADE. It's clear that the angles are coded. Here we have two right angles at B and at D. Now BE is the measurement of that segment. It's equal to 15, as well as DE is equal to 3 radical 2. We have two obtuse given angles, FAE, that's equal to 150 degrees, and another one that's BAD, that's equal to 135 degrees. Now I have to let you know that pay attention not to say that FAE and BAD are vertically opposite angles. They are not, because F, A, and D are not collinear, as you notice. And now let's start with the first part. In the first part, we have to find the nature of triangle EDA. Now, as you see, here you have a right angle, and here we have an angle that's given equal to 135. So clearly we can find that small acute angle here. Now to find that acute angle here, which is called EAD, all what we do is to subtract 135 from 180, and what remains for EAD is just 45, because the angles BAD and EAD are called supplementary or linear angles. They make a straight line, they make a straight angle that's measuring 180. So that angle is equal to 45. That angle is equal to 90. So what remains for that angle? You have to know directly. In any right triangle, if there is a right angle here, then what remains for the other two is 90. So if one of them is 45, then the other is gonna be 90 minus 45, which is exactly 45. Then that angle is also equal to 45, and that defines a right isosceles triangle. So ADE is called the right isosceles triangle because it has two equal base angles that's equal to 45 each, and one right angle, as it's obvious here. Thus ADE is a right isosceles triangle. Now we can deduce that the sides are equal, and that side is 3 radical 2, so that side is 3 radical 2 also. Now let's move to part 2 to see what we have to do, and you should expect what we have to do in part 2. We have to calculate AE. We have to deduce that AE is equal to 6. Then AE is what? Let's specify AE. AE is the hypotenuse of that right isosceles triangle. Thus, AE is equal to the side multiplied by radical 2. Now let's talk a little bit where this property comes from. If we have two equal sides in any right isosceles triangle, let's call it in general S, and we apply Pythagoras in that right triangle, then we are going to get that hypotenuse squared, that's Pythagoras, equals to S squared plus S squared. That's what Pythagoras say. So hypotenuse squared is equal to 2S squared. Now to get hypotenuse alone, we have to make radical for both sides, and thus we have to write it like S into radical 2. S squared will be will be written as S, and 2 will be kept under the radical, and that's where that property comes from. So directly we have to apply it. We just multiply this side by radical 2, and we are going to get 3 times 2, which is 6, and that's verified as required here. And the reason is because it's the hypotenuse of a right isosceles triangle. Now I have to tell you a note that I always keep telling at class, which is, suppose that I have the hypotenuse and I need to find the side. What should I do? So the hypotenuse, if you remember, I just wrote it, is equal to side times radical 2. Now if I have the hypotenuse and I need to find the side, what should I do? All what I do, I have to divide the side is equal, conversely, is equal to the hypotenuse divided by radical 2. You have to keep this in mind. So the side, that's required side, this or this, both of them are equal. It is equal, for example, if I have the hypotenuse equals to 6, then all what I do is to divide 6 by radical 2. So to find the hypotenuse, we multiply the side by radical 2, and to find the side, we divide the hypotenuse by radical 2. Now here we can use the help of the calculator. We can divide 6 by radical 2, and the answer is gonna be, as you see here, 3 radical 2 for the side. Okay? So that's if we have the hypotenuse and we need to find the side. But if we have the side as we have here and we need to find the hypotenuse, all what we have to do is to multiply by radical 2. Let's continue and see what we have in part 3. Now in part 3 we have to show that triangle FBA, that triangle FBA is a semi-equilateral triangle. Now, to prove a semi-equilateral triangle, we can use either angles, as we are going to do here, or we can use sides. What do I mean by using sides? Let's take a note here. If I have a right triangle in such a way, I have a right triangle, as you see here, in such a way, the smallest side here, for example, equals 3, and the longest side, which is the hypotenuse, of course it's a right triangle, for example, is equal to 6. Or the smallest side is equal to 4, and the longest side, which is the hypotenuse, is equal to 8. Or the smallest side, for example, is equal to 5, and the largest side, which is the hypotenuse, is equal to 10. What do you notice? What's the relation every time between the hypotenuse and that smallest side? We notice that that smallest side is always half of that hypotenuse, or we can say that hypotenuse is always double of that side. Then this is definitely a semi-equilateral triangle, and here is the angle 30 that's facing that smallest side. So if we have a triangle in such a way, it is right. That's the first condition, and the other condition is that the smallest side of this triangle is equal to half of its hypotenuse. Then definitely this triangle is semi-equilateral, and the angle facing that smallest side is the angle measuring 30 degrees, and of course 60 remains for this angle. So that's what I mean by proving a semi-equilateral triangle using the sides. Now let's go back to our part, and in this part we are going definitely to use angles, because as you see here we have an obtuse angle that's measuring 150. Then definitely what remains for this inside acute angle is 180 minus 150, which is 30. So here we get 30 degrees. Here we have definitely 90 because it's given, it's coded. So what remains for F? As I told you previously, the sum of these angles is 90 definitely, because here we have a 90. Then what remains for this is 180 minus 90. So what remains for F is 90 minus 30, which is 60, and we have to write because it is a remaining or the remaining angle. Now triangle AFB is semi-equilateral because the angles of it are 90, 60, and 30. Now in part 4, I guess we are going to calculate sides, because usually after proving semi-equilateral triangle, we have to calculate sides. Note that in a semi-equilateral triangle, it's enough to have one side in order to find the other two. Any triangle has 3 sides, and also a semi-equilateral has 3 sides. It's enough to know one of them, either the hypotenuse or that facing 30 or that facing 60. Whenever we know one side, we can find the other sides. While in any right triangle, an unusual right triangle, we have to know 2 sides in order to find the third. So we have to know 2 sides in order to have the third. We cannot only have one given side. We must have 2 given sides. While in a semi-equilateral triangle, it's enough to have one given side. And let's continue. In this semi-equilateral triangle, let's specify what side do we have and what side we have to find. We have to calculate FA. We have to calculate the hypotenuse. We don't have the hypotenuse, so we have to calculate it, and then we have to calculate FB. So we have to find the hypotenuse first, and then we have to find FB, which is facing 30. So definitely we should have that facing 60. Let's see. Remember, at the beginning of the exercise, we said that BE equals 15, and we haven't used it yet. So here we are going to use it. BE from here to here is equal to 15. We proved that AE is equal to 6. So definitely what remains for BA is 9, because 15 minus 6 is 9. So BA is equal to 9. Then BA is the side facing 60. So we start writing the rule of the side facing 60. BA equals FA times radical 3 over 2. That's the rule of a semi-equilateral triangle concerning the side facing 60. So that BA, which is given, is equal to that hypotenuse that we are going to find times radical 3 divided by 2. So all what we do now is to write it. 9 equals, we have to substitute in place of BA its value, FA times radical 3 over 2. We put 9 over 1, we cross multiply, and we have that FA times radical 3 equals 18. So we get that FA times radical 3 equals 18. And to keep FA alone, we have to divide by the number multiplied by it, which is radical 3. Using the help of the calculator, we can directly divide 18 by radical 3 to get, so 18 divided by radical 3, or we can put it as a fraction, never mind. So the answer is, as you see, 6 radical 3. Thus FA, which is the hypotenuse, is equal to 6 radical 3. Now we find the hypotenuse. What remains is to find FB. Now FB, since it is the side facing 30, is equal to the hypotenuse divided by 2. And since the hypotenuse is 6 radical 3 as we found it here, then BF is equal to 6 radical 3 over 2, which is 3 radical 3, half of the hypotenuse. Now, dear students, I'm going to talk about a note that you may use in solving exercises concerning semi-equilateral triangles. Suppose that you have given that side. You have FB, which is the side facing 30. And you know that this triangle is semi-equilateral and you need to find the hypotenuse. Guess how much is the hypotenuse? You can find it directly. If the side facing 30 is 3 radical 3, then how much is the hypotenuse? Of course, it's double of that side, because you know that the side facing 30 is equal to half of the hypotenuse. then definitely the hypotenuse is going to be double of that side. So it is 6 radical 3. So please keep this note in mind. It's also an important idea. So whenever you have the measurement of the side facing 30, then all what you have to do to find the hypotenuse is to multiply that given side by 2. Because the hypotenuse is always double of the side facing 30, and the side facing 30 is always half of that hypotenuse. Now let's move to part 5. I guess there is a very nice idea to get in part 5. In part 5 we have to find the length of FE. Now FE is that side. So we have to search for a right triangle including FE. It is definitely FBE. So in triangle FBE, that's right, we apply Pythagoras. So F in right triangle FBE, we apply Pythagoras. So in right triangle, we have to specify the triangle FBE. Pythagoras say that FE squared equals FB squared. So FE squared equals FB squared plus BE squared. Let's remember what is FB. FB is 3 radical 3 and BE is 15. So we just square the numbers. FE squared is 3 radical 3 squared plus 15 squared, which is 27 plus 225, which is 252. Again, we use the help of the calculator because to get BE, we have to make radical 252. So using the calculator, we just press the radical 252 and we press equal, then the calculator gives 6 radical 7, so FE is 6 radical 7. So we use Pythagoras here because that triangle FBE is not a right isosceles triangle, neither a semi-equilateral, and we have two sides that are given, so we just apply Pythagoras to find the missing side, which is the hypotenuse here. And finally, we move to part 6. In part 6, we mix algebra with geometry. We mix algebraic expressions with geometry, and I adore such kind of questions and ideas. So we have to find a real number x that's positive, greater than 0 means positive, knowing that x squared minus 6x plus 18 equals s, where s is the area of that right isosceles triangle ADE. Again, we are going to use AD. So S is the area of that right isosceles triangle. So first of all, let's find that area. In a right isosceles triangle or in any right triangle, we can use the sides as height and base. So we can multiply ED times DA as a height and a base. Okay, that's a property of a right triangle. We can use the sides as heights and bases. So the surface or the area is equal to AD times ED divided by 2. Then S is equal to 3 radical 2 times 3 radical 2 divided by 2. Now radical 2 and radical 2 give 2. So we get 3 times 3, 9 times 2 over 2, which is 9. Thus the area of that right isosceles triangle is 9. Now we form the equation using the given. The given says that x squared minus 6x plus 18 equals s. We just evaluate in place of s its value. Then x squared minus 6x plus 18 equals 9, that value. We take 9 to the other side, we subtract, then we get that. And that is an identity indeed. X squared minus 6x plus 9 equals 0. Whenever we see equal to 0, we have to factorize, as you remember. So we factorize that. It is an identity. We look at these. X squared comes from x and 9 comes from 3. Then we have to write it as x minus 3 squared to make sure we multiply x by 3 and by 2 we'll definitely get 6x. Then x minus 3 squared is 0, so x is 3. We call it a double root. and it is accepted. Why is it accepted? Because the condition says that x must be a greater than 0 number, which is a positive number, and 3 is satisfying that condition. That's why we write accepted. Hope you enjoyed that training exercise. Inshallah, we'll meet in another video talking about another training exercise.